making your development and release practices more agile, allowing your business to quickly adapt to changes. Additionally, it provides a set of guidance to ensure workload quality through standardized processes and teams cohesion. Operational excellence is achieved through a combination of principles that ensure effective team organization, continuous improvement, and proactive engagement of workloads and processes. So how can we establish development standards, and what are they? Well, development standards, they help to optimize productivity and ensure high-quality outcomes. First, it's crucial to implement standard development practices, quality gates, and change management processes. These elements are the backbone of our productivity and help us maintain consistency across the board. One of the core design principles is to document features, non-functional requirements, otherwise known as NFRs, and sizing estimations. By documenting workload features and user benefits, we ensure that everyone is on the same page. We also need to document both functional and non-functional requirements and create accurate sizing estimation models. Next, we should also adopt a standard methodology with a shared backlog using an industry standard software development lifecycle, SDLC methodology, and maintaining a shared backlog among all rows helps streamline our processes and improve collaboration. Unified source control and a branching strategy are also essential. We need to use unified source control for all code and ensure that our branching strategy supports friction-free releases. Sharing knowledge across the organization is key to achieving this quality assurance, and it should be integrated early in your SDLC. Our QA processes should emphasize testing early on, including all artifacts for planned test procedures and treating these artifacts as immutable. Consistency throughout the SDLC is another important aspect. We should drive consistency by using style guides and tools and by adhering to development standards, such as API design, logging, and exception handling. Continuous planning is vital for your success. This includes strategy and portfolio planning, release planning, sprint planning, agile requirement management, and security measurements. So for continuous integrations, you need a solid branch strategy, shift-left testing, gated check-ins, test-driven development, or behavior-driven development. Build a pipeline, software composition unit, and the list goes on. So with continuous quality, it involves meeting quality requirements, adhering to governance and standards, ensuring compliance and audits, and implementing both shift-left and shift-right testing. By establishing these development standards, you can create a robust and efficient development environment that supports your goals and drives continuous improvements. Now, when we think about evolving operations with observability, you want to build a culture that continuously improves quality by monitoring the workload and taking all the pillars of the Azure well-architected framework into consideration. Enable the team and stakeholders to make both short-term and long-term decisions across many facets by providing the necessary data, statistics, and trends. Learn from your data and drive improvements. Monitoring operation is key in proactive maintenance of the application, quality and security assurance, capacity planning, and product management. A crucial aspect of monitoring is application health modeling. That helps you anticipate issues before they become incidents and affect customers' experience. Efficient monitoring reduces reactive cycles spent on incident management. So when we think about deploying with confidence, this is like reaching your desired state of development with predictability. So to do that, you want to build a workload supply chain that enables you to consistently reach the goal of predictability in all of your environments across the workloads, hosting platforms, applications, as well as your data and configuration resources. The deployment mechanism must be capable of automation, testing, monitoring, and versioning. It should be modularized and ready to execute on demand. It shouldn't be represented as a monolithic end-to-end process. The supply chain isn't necessarily for faster execution, but to achieve consistency and self-documentation over multiple iterations. The workload team is accountable for the supply chain as it relates to their own workload. Though automate for efficiency is also part of your workload, and the workload might have workflows with processes that involve team members doing mundane, repetitive, and time-consuming tasks that don't actually need human intellect. Depending on the frequency, you might spend considerable time on these efforts, investing more time as the workload grows. Also, these processes are often error-prone due to human input. Through automation, you save time, effort, and money, and you avoid those costly mistakes. Adopt safe deployment practices. During the development cycle, workload artifacts go through many changes as they get implemented and tested. And as bugs are fixed, the deployment processes must follow a standard operating procedure. Any change must be deployed with the same level of rigor. This principle applies equally to code, configuration, and all related artifacts. The key is to apply safe practices as early as possible so that you have predictability in production. Even if errors reach the customers, you should be able to roll out recovery changes as soon as possible. DevOps is a community of practice where diversity of perspective and skills drive towards one mission. Teams must foster a collaborative environment of shared knowledge instead of siloed learning. Use shared functions to strive to overcome resource constraints. A good DevOps culture thrives on shared responsibility. Development and operations teams should align their goals and priorities with the expectations of their customers and keep business focus in mind. The development team should involve the operations team in the feedback loop so the improvements are driven upstream and other teams benefit equally. Conversely, operation teams are responsible for making the development team successful in their business outcomes by sharing resources and feedback that are relevant to the workload. At the same time, DevOps practices apply clear lines of ownership and accountability to each team. Regardless of where the application runs, the workload team is responsible for that application. DevOps optimizes operational tasks so that they're effective but not burdensome. To recap the full benefit of DevOps, the culture should optimize processes through technology and have processes for people in the organization to promote a transparent communication. There are 12 checklists, as you can see on this slide here, for OPEX. Focuses on both human aspects of things along with technical implementation across this pillar. All points need to be considered for bringing in confidence in architecture. Code 01 helps identify which checklist items we're referring to. And as you can see, they're written out as, here, let me write this on the slide here for you. You've got RE, which is your reliability. You also have SE, which is your security. And then you have your CO, and you can see where we're going with this, your cost optimization. Don't think I'm going to fit that on the slide. Here we go. And then you've got your PE, right, which is your performance efficiency. And let's see if I can spell this right. There we go. So those acronyms, as you can see in here, those are what you're going to see a lot referenced in your checklist for your operational excellence. So let's take a look at the operational excellence trade-offs and discuss how they impact other pillars of the well-architected framework. The first one we're going to look at here is reliability. While operational excellence aims to increase efficiency and streamline processes, it can also introduce complexity. This complexity can lead to potential destabilizing activities as higher frequency deployments and increased density can increase the chances of misconfiguration. Reliability, on the other hand, favors simplicity to minimize misconfigurations and avoid unexpected interactions. Next up is security. Now, with operational excellence, often increase the workload surface area by adding components like automation or custom control planes, which must be regularly hardened and tested for security. This increased surface area can introduce more attack vectors. Security aims to reduce the workload surface area and protect the confidentiality of data. Now, when it comes to cost, operational excellence can lead to increased resource spending, implementing automation, training, and standard processes can divert focus from delivery activities and increase tooling demands. Cost optimization, however, looks to reduce resource usage and tooling sprawl, preferring a right-size approach to all tooling purchases. Lastly, let's consider the trade-offs between operational excellence and performance efficiency. Operational excellence increases the resource utilization due to the level of instrumentation on the system, which can strain resources. Performance efficiency, on the other hand, strives to allocate as much of the available compute and network resources to perform the workload requirements. Additionally, operational excellence can introduce latency through deployment models that use gateway routing access patterns, while performance efficiency aims to reduce time spent and resources consumed. So understanding these trade-offs is crucial for making informed decisions that balance operational excellence with reliability, security, cost, and performance efficiency. So let's get into more about performance efficiency, so our next pillar in here. So to design to meet the capacity requirements, the goal is to provide just enough supply to address anticipated demand. It's essential to balance supply and demand, evaluate the scalability requirements for your critical flows to ensure that your system can handle the expected load. Eliminate performance bottlenecks by utilizing appropriate design patterns such as caching and sharding. Choose the right services and SKUs, balance resource allocation and system requirements to avoid or under provision. Capacity planning and predictive modeling are crucial for forecasting future load. By doing this, you can anticipate demand and ensure that your system is prepared to handle it. Validate your performance target using a proof of concept to ensure they are realistic and achievable. Document your performance testing and monitoring strategies to maintain a clear and organized approach. The goal here is to provide just enough supply to address anticipated demand. This means you need to be proactive in your planning and continuously monitor and adjust your capacity by needed. By following these principles, you can design a system that meets capacity requirements efficiently and effectively, ensuring optimal performance and user satisfaction. So let's get into this a little bit more. Let's talk about negotiating realistic performance targets. To negotiate this, start by understanding business requirements and constraints. Anticipate growth based on historical data, not assumptions. Collaborate with the business owners and subject matter experts to define performance targets for critical user flows using industry standards like percentiles. Build a performance model considering typical usage patterns, business criticality, and cost optimization or cost operation, constraints. Gather metrics to provide historical insights into usage patterns and bottlenecks. Use external factors like market analysts and industry standards to make informed decisions. Identify and prioritize workload flows in the architectural diagram, defining performance tolerance ranges. Evaluate entry and exit points for each flow. Consider criticality, usage frequency, and architectural intensity. Incorporate growth prospects to ensure targets remain realistic and achievable over time. Now, when we look at achieving and sustained performance, it's essential to integrate routine performance tests into your DevOps pipelines. We've talked about this before. These tests should be formalized as quality gates to ensure that performance standards are consistently met. Set up performance monitoring and learning processes in production. Continuously review performance test results and telemetry to identify trends, bottlenecks, and deviations. This proactive approach helps in maintaining optimal performance over time. Building coding skills that focus on performance is crucial. Encourage your team to investigate performance degradations and reset expectations when necessary. This continuous learning and improvement mindset will help in sustaining high performance levels. By following these practices, you can protect against performance degradation and ensure that your systems remains efficient and reliable. Improve efficiency. This is all through optimization, and this is going to do, what you're going to do with this is increase your workload value. It's essential to allocate dedicated time and resources for performance optimization. This helps a performance-driven culture within your team. Continuously innovate and look for ways to optimize system performance by adopting the new architectural patterns and technologies. Focus on optimizing areas where the gains are the highest and maximize the impact of your efforts. By following these practices, you can ensure that your system remains efficient and continues to deliver high value over time. Now, the checklist for the performance efficiency, there are 12, and it focuses on both business aspects of things along with technical implementation across the pillar. All points need to be considered for bringing in confidence in architecture. The codes PE01 help identify which checklist item we are referring to. Now, there's a customer use case by the National Healthcare Agency of the UK. They face unprecedented challenge with COVID-19, experiencing traffic surges to 25 times the previous peak load. The NHS digital team needed to quickly understand and address the root of the problem. So what they did is they turned to the Microsoft Azure well-architected framework and the mission-critical architectural approach to diagnose systematic issues and implement a more responsive system architecture. This helped them scale with the demand and maintain performance level. A compelling success story. You can see this full story in a link after this workshop if you want to read more. So now let's look at the trade-offs with performance. The first one there, reliability, is performance efficiency can increase complexity and risk of misconfiguration, while reliability favors simplicity and redundancy. And with security, it may bypass security measures and increase the workload surface area, introducing more attack vectors. When we look at performance versus cost optimization, it can lead to higher costs due to additional components and premium SKUs. And then when we look at operational excellence, performance improvements may reduce visibility into system operations and increase operational complexity. Conflicting with operational excellence practices, understanding these trade-offs help balance performance efficiency with reliability, security, cost, and operational excellence. Now, when you evaluate your cloud readiness using Microsoft assessments, this is to ensure your organization is prepared for cloud migration at scale. Microsoft offers several assessment tools. You've got the strategic migration, the Strategic Migration Assessment and Readiness Tool. This tool helps you understand your organization preparedness for implementing a cloud migration at scale. It provides insight into your current state and identifies areas that need improvement. You also have your governance benchmark. This assessment identifies gaps in your organization, current governance practices, and provides curated guidance on how to address them. It helps you establish a strong governance framework to support your cloud journey. And then the last one there is your well-architected review assessment. This review helps you optimize design decisions and trade-offs within your workload architecture. It provides recommendations based on best practices to ensure your workloads are reliable, secure, and efficient. Using these assessments, you can evaluate your cloud readiness, identify areas for improvement, and implement best practices to ensure a successful cloud migration. This concludes session 5, where we discussed understanding each WAF pillar, discovered how to use the WAF pillars, and finally learned how to optimize workloads using pricing, Microsoft Cost Manager, and Azure Advisor. Now let's take a quick 10-minute break before starting session 6. Use tools to optimize your cloud spend. Welcome back from the break. Let's move on to session 6, where we'll discuss the tools to optimize your cloud spend. So now let's talk about using tools to optimize your cloud spend. So the learning objective in here is capacity planning, pricing, and optimization, and how to understand these. So the first one in here is we've got manage and optimization. Right? This is an automated identification of architectural deficiencies. First, let's delve into the automated identification of architectural deficiencies using Azure Advisor. By utilizing, and what did I call Azure Advisor before? Your cloud consultant. So by utilizing telemetry data related to your deployed workloads, Azure Advisor can pinpoint areas where your architecture is not performing optimally. This data-driven approach allows us and you to identify issues quickly and accurately, ensuring that we can address them before they impact your operations. Now, leveraging the well-architected framework, Azure Advisor offers recommendations aligned with the WAF to help you remediate deficiency. The recommendations are based on usage data for a certain set of configurations of resources or resource groups within an Azure subscription. By aligning our remediation efforts with these recommendations, we can systematically address any deficiencies identified and enhance the overall performance and resilience of your Azure architecture. Now, the Azure Saving Plan for Compute and Reservation recommendation, the Azure Advisor also provides pricing plans, including the Azure Savings Plan for Compute and Azure Reservation. These plans enable us to optimize our cloud spending by committing to 1 or 3-year term for compute resources, leading to significant cost savings. The Azure Advisor will analyze your current usage patterns and identify the most beneficial plans to reduce your operational costs without compromising performance. It'll essentially tell you, hey, look, you're running a workstation that's only has 10% utilization, and you're using, a pay-as-you-go. How about you do a reserved instance with the lower SKU and so on? And so that's what the Azure Advisor can help you with. Now, there's a customer use case for WAF using cost optimization, and it was ASOS, right? ASOS or ASOS, however you want to say it, initially didn't prioritize cost optimization, and they were focusing instead on developing new features, like most companies. However, the pandemic forced them to reconsider in order to remain financially stable. Implementing a cost optimization strategy became crucial to manage costs and avoid furloughs. These were initial concerns that reducing spending would stifle creativity, but the opposite happened. ASOS benefit from efficiencies without sacrificing much. The team quickly adapted, and within weeks, they saw significant improvements. The culture shifted, and their cloud cost optimization has already saved them 25 to 40%. You can read about that case study after the workshop in one of our links. So now let's talk a little bit about our interactive guide that you're going to be able to do. This is the rate optimization one.
So the interactive guides, you've seen them before. They're very helpful for you to walk through. This one takes approximately 7 minutes. And what this one does is it walks you through, how to, and I'll read it right here, how to implement rate optimizations with the FinOps. So expect for this one in here, and you just follow the prompts, is you're going to go in and you're going to create a virtual machine. Once you create that virtual machine, I'm just going to go through this quickly here because you're going to do this in a demo. You're going to learn more in here. So in here, let me just actually go back a little bit, kind of jump too quickly there. In here, when you're looking at different types of options, a lot of times what you'll see in the portal is it'll give you information about, how you can deploy these services with cost optimization. So when I click on learn more in here, this takes me to the hybrid benefit, and you can read up more about that. And then if I want to use it, then I can. And this, again, will require that you have server licenses. So you have a software assurance or you have a Windows Server subscriptions that you can pull into the Azure environment. Right. And then in here, I can also get more Azure Advisor recommendations for my cost optimization. And it'll give me an idea of, what is, the virtual machines that the advisor has identified that can give me the best low usage. And then I can view that usage patterns in here. So I'm not going to walk through the rest of this, but you'll be able to go in and see all the different and see the recommendations. What is the expanded recommendations for each virtual machines? And then based on those recommendations, you can look at the advisor and it can further give you more recommendations. And so that's working through the rate optimization interactive guides that you'll get access to be able to try that out later.
So let's move on to our Microsoft Cost Management and the learning objectives for this. So in management, Microsoft Cost Management includes several functionalities to help you manage and monitor your costs effectively. You can set budgets and monitor costs, review forecasted costs, and identify spending trends to make necessary action. Cost analysis and cost management supports most Azure account types and allows you to view cost data with at least read access for an Azure account. You can also create budgets and alerts to notify stakeholders of spending anomalies and overspending risks. Additionally, you can export your cost data to a storage account for further analysis by finance teams using tools like Excel or Power BI. In the next slide, we'll go over an interactive guide to show you how Microsoft Cost Management comes to life. So this is the forecasting one. And when I click on here, same thing, it's going to open up in my browser. With this interactive guide, it's designed to help users optimize their cloud costs using FinOps on Azure. It covers various aspects of cost management, including analyzing and tracking cost spending, identifying cost savings opportunities, and implementing FinOps best practices. This guide provides you with a step-by-step instructions on navigating the Azure portal, using Microsoft Cost Management and customizing views to better understand and manage cloud costs. The script emphasizes the importance of monitoring and optimizing cloud expenses to achieve financial efficiency. This guide also provides detailed instructions on navigating the Azure portal and using Microsoft Cost Management to analyze and monitor cloud costs. Users are guided through various features of Microsoft Cost Management where they can access views to analyze, monitor, and optimize their cloud costs.
In this demo, I'm going to go through forecasting. This demo is also using an interactive guide. So let's take a look at that. So in here, this is an interactive guide that you'll be able to get after the class or when they post the links. This interactive guide is designed to help users optimize their cloud costs using FinOps on Azure. It covers various aspects of cost management, including analyzing and tracking cloud spending, identifying cost-saving opportunities, and implementing FinOps best practice. It gives you a step-by-step. So here, let me start it up. So in here, when you start it, and I've muted the sound as usual, but you'll be able to follow along over here on the right-hand side. You can read what's being prompted. And then in here, all you have to do is just kind of go through each of the prompts. So in here, I'm going to click on change. And then this fictional company that we're using for this interactive guide is Trey Research. Click on that and we're going to go through the billing account. So you can see in here, we're in the cost management tool for this fictional company. And we're going to go through and do some cost management and customize some views so that you can understand and manage your cloud costs. So this script will go through the importance of monitoring and optimizing cloud expenses to achieve that financial efficiency. So in here, when I click on cost analysis and click all views, and then click on scroll, I can see that there are customizable views that I've created. And from there, I can go in and I can pin them. That way I can get to them quite quickly. So every time I go into this tool now, I'll be able to get to my accumulated costs right away because I've pinned that. And you can go ahead and click on any other views, create your own views and pin them so you can get to them quite quickly, as you can see. So throughout this, you'll go throughout this interactive guide, you're going to go through and look at some of the prompts, and you're going to go through and scroll through them and, go through and look at the different costs and all of that. So that's a little bit about the forecasting interactive guide. And again, you'll get a link to that so that you can run through that guide. Thanks.
So we've already talked a little bit about Azure Advisor, so let's kind of get more into it. So Azure Advisor is your free personalized guide. What do I always call it? Come on, everybody, you should know by now. Yell it out. Yes, it's your cloud consultant. I like to call it that because here's the key word. It's your free cloud consultant, because we know how expensive consultants can be. So they deserve money. But so with Azure Advisor, it's your free personalized guide to Azure best practices. It is aligned to the well-architected framework in that it makes it easier to optimize your Azure resources for cost, security, performance, reliability, and operational excellence. So all your WAF pillars. The recommendations are based on usage data for a certain set of configurations of resources or resource groups within an Azure subscription. The alerts and prioritizations are based on severity and number of resources impacted by detected architectural deficiency. Thus, you, the IT administrator and developer, can quickly determine which recommendation to remediate first. So how does Azure Advisor work? Essentially, it scans your resources, usage, and telemetry and configuration, and surface relevant best practice recommendations from the many Azure services. And the recommendations are based on the usage data. So we get that information from our customers and what's happening in the world today. So when you're thinking about the Azure Advisor, one of the key things that I always recommend is don't just look at it once and think, oh, okay, I fixed it. It's all done. Moving on. Always consistently monitor that Azure Advisor, because as we know, security breaches, things change, cost changes. We might be releasing a new product or feature that might be more cost efficient than currently what you're using. So Azure Advisor is a tool that's something that I would recommend that you consistently monitor and look at. And that way it can support your growth in all of the WAF that you can see. This concludes session 6, where we discovered the essentials of Microsoft Cost Management to help you optimize workloads and bolster FinOps. We'll take a quick 10-minute break before starting with our final session 7, the case study to review and remediate a workload deployed in production. Welcome back from the break. Next up is our final session, session 7. This session is a case study that discusses review and remediate a workload deployed in production. Okay, so let's walk through this case study together. And this case study is going to focus on reviewing and remediate a workload deployed in production. I'm just going to flip to my screen here, my screen share. So this workshop, as you can see, it's a workshop that you can do, and there is 7 exercises, and you will get access to this link in this VTD. So let's kind of break it down first before I get into the actual workshop. Let's kind of go through this. So you can see exercise 1 is understanding the existing architecture and reliability implications, say that word. And then exercise 2, discover and generate RAF recommendation using an APR script. We'll talk about what that is. And then exercise 3 is reviewing the action plan and prioritize recommendation. You got exercise 4, which is generate reports from the action plan. And then exercise 5, which talks about applied critical updates to the Azure environment. And then exercise 6, which is rerun the APRL script to generate updated action plan. And then finally, there's an optional exercise that introduces faults to validate resiliency. So let's go ahead and get into this. I'm going to start the workshop. So as you can see, it's going to start with the one, and as you can see, this is one of those interactive guides, right? And you've seen them before already in this virtual training days, and I'm just going to walk through it in here, and I'm going to make sure I mute. Okay, so this is the one that's going to understand the existing architecture and reliability implications. And so with this, what we're going to talk about in here, and let me just pause this, is we're going to explore existing application architecture on Azure. We're going to conduct a thorough reliability assessment. We're going to prioritize recommendations and apply updates. And then we're going to rerun assessment and validate improvements. So as we go through it, we're going to skip that. And then this kind of just talks about that. I'm just going to skip that as well. And then here's our task. So we're going to review the existing architecture and explore reliable design principles. So in here, as you can see, we currently have an architecture and components. And what we have here, and I'm going to pause this so it doesn't jump ahead of me. Let me take that off there first. Is what we have is we have an end user, and that end user is coming in through a public IP. You've got a network set up in your Azure environment, and you have, as you can see in here, 3 subnets. And so with those 3 subnets, they're broken down into what is the workloads that are running in those subnets. The front end subnet it looks like it's going to be your web application. And then you've got your DB subnet, so that's going to be your data. And there's another data subnet, right? So you've got your SQL and your databases separated in the 2. And so that's what we're looking at when it comes to the environment. So now what you want to do is you're going to click on this, or we're going to look at this WAF reliability. And in here, what we're going to do is we're going to look about how to work with that WAF reliability. I'm just got to kind of go through this. And we're going to do this on the virtual network. So when we expand settings and go into our subnets, you can see the 3 subnets, and there's their IP address range and so on. And so now what we're going to do is we're going to go into that IP address. So remember, this was the IP address that was connected to connected to the public, right? Hence the PIP, so your public IP address. And in here, you can see the overview of this public IP address, and it's one that you use to browse the web app that's hosted in here. All right, it says close the window. Let me scroll down. So there's the IP address. So now let's close that. So now there's your web VM. So that was in the first subnet. And in here, what we're going to do, we're going to copy that IP address, right? And that's the public IP that's connected to your web app, right? And then we're going to open up a new tab in here. And then in here, you can see this is the custom virtual machine page of that IIS web server. So essentially what happened is we pasted that IP address in there, and then that IP address, it defaulted to this page to give us information about that app, that web server. Right? So remember, it's a web server, then you got connected to your SQL database, and then your storage account as well, all in one virtual network. Let's get back out of here. So now we're going to go in here, and we're going to look at the availability and scaling. Right? So in the application goes down, or is this specific availability zone has the outage, right? So in here, now let's scroll down in here. I don't know what it's doing here. There we go. It's a little bit delayed here for me. So now we're going to go into the SQL database, take a look at this, right? Look at the replicas. So we can see there's none in here, right? So no replicas found. And then we're going to go into the storage account, expand that, and look at that redundancy. Right? You can see that the primary data center that it's using is in central US. Okay, so now that we looked at that all through the portal, well, let's take a look at how, what are some reliability design principles and considerations that we can implement to support, a better reliable environment, really, using the WAF and all that we've learned. So let me go into a whiteboard first. So we had a person who wanted to connect, and people that want to connect that are sitting on a public connection. They're going to go in and they're going to connect to your web application. Right? That web application is sitting on an Azure VNet. It has its own subnet, has its own public IP, and then there was two other subnets that we saw. We also had a SQL database, and we had a storage account. And they also had their own, the DB subnet. And then we had our storage subnet. Now, here, let me put this as the web subnet. Oops. Getting a bit of a delay here, and there we go. It's going to come. It'll just show up magically as I'm writing. So what we want to do is, actually, when I look at this just environment, and I'm sure all of you hopefully are looking at it, or some of you are looking at this environment going, ugh, there's no reliability here, right? There's nothing here. Like, if, for example, this web application goes down, guess what? There goes your app, right? Nobody's going to be able to access it. So when we go back to this redundancy, or look at these key reliability considerations, the first one in here is we look at redundancy. So now let's go back to this whiteboard and think, how can we make this more redundant? And the question you have to ask yourself or find out is the web application itself, what is that application you run on there? And is that application requiring, or going through what we call peak performances? So for example, think of a company, let's say you're a streaming company, or you're e-commerce, right? You're selling a product, and you release a new product, and that product is going to, hit the web application, and you're going to get lots of sales and a lot of people wanting to purchase that product. It's kind of like, with streaming companies, they release a new episode every week, and as soon as the episode gets released every week, they're going to get a lot of people hitting that. So when we think about peak performances, having one web application is going to cause, give you, not be able to meet the performance. And if that application goes down, you're going to run into situations. So how we can make this better is we can look at, instead of having that single environment, we can have our user sitting out here, again, still in the public connection. And you still have your virtual network. The idea of having multiple subnets, again, I'm not going to go heavy into it. You could have one subnet and use what we call application security groups. And you'll learn more about that as you move on and start taking, Azure Administrator course and Architect courses. But for this example, I'm going to keep it quite simplified. I'm just going to keep the 3 subnets. But instead of having a single web application, how about instead you deploy a virtual machine scale set, right? That virtual machine scale set, not only is it going to be redundant, right, and help with that redundancy, but it also is going to meet your performance. Now, you could also do, so this is, if you're wanting performance, then you want that virtual machine scale set. But if you're looking at something that you know, my environment has a steady performance, I don't go through peaks, then you can look at what we call availability sets, right? And this will give you that redundancy, meeting, you know, a lot of times the SLAs that you require, right? So that's going in and doing that. And you can also do that for your databases, right? Now think with your databases, I can start putting in replicas, and that will help with that environment, right? So implement replicas in there. Okay. So the other thing is about backup and restore, right? So when we look at backup and restore, you know, especially if you're working with compute workloads, and especially when you're working with data, right? You have multiple data resources that you're using. You're using what we call databases as well as storage accounts. So what you want to do is make sure that you're backing up copies of that data, right? And SQL has that backup capability. And then the other thing is monitoring. Monitoring also includes, you know, consistently doing that. And when we think of monitoring, when I go back into this environment, there is a tool or service called Azure Monitor. Now, Azure Monitor has 3 things associated with it. You can do logging. What's the other one? Metrics, sorry. And then finally, you can do alerts, right? So when you look at the different capabilities and you think about it all, well, here I can go in and I can start now logging, you know, my virtual machine scale set, right? Now I want to see, you know, what is my usage on my availability set? Well, I can use metrics and see what's going on with that. And then if I run into, you know, let's say I see, you know, 80% CPU, then what I can do is I can be alerted on that by getting an email, a text. I can even get where it can run a workbook, something that happens like, you know, a PowerShell. So basically an automated thing that can happen. And that's kind of what virtual machine scale sets are, right? When you build your virtual machine scale set, you apply these metrics, and then you specify, you set these alerts on these metrics, and then when that alert is triggered, something happens. And with virtual machine scale sets, you will scale into another machine, and it'll build another machine. And it's all, the big thing there is it's all automated for you to do that. So the other thing too, and we kind of already covered this, is the scalability, right? So once you've set up your monitoring and alerts, and you know, again, thinking about whether you want to meet performance or if you need to meet performance, then you can go in and you can scale all of this, right? And the scalability options, as we saw, there was 2, right? You got your availability sets, as well as you've got your virtual machine scale set. And the difference between the 2, as I was saying in the slide or in my whiteboard, is virtual machine scale sets are to meet performance and give you redundancy. Whereas availability sets are essentially, you know, gives you the redundancy for machines that, you know, don't go through those performance. And then you've also got disaster recovery. So disaster recovery involves planning. So in this environment, we saw, let me go back over here. I'll scale back over here. In the original setup here, we saw that this was set up in central US, right? So what if in this environment, your virtual machine goes down, right? Or even in this environment, the new one that I created over here, even if this goes down, right? Like the region, you get into your region goes down or whatever, you're not protected, even if you've got 100 virtual machines running. So what you want to also think about is disaster recovery. And when we think about disaster recovery, what can we use for that? Well, what we can use is we can use our Azure Site Recovery. And the Azure Site Recovery is part of our backup services. And so what you could do is you can actually do a failover to another region. And I'm talking about this at the web app level. Right? Now, databases are a bit different. Databases, you would use replicas or secondary replicas over across regions. And then storage accounts, you can duplicate them, right? So you can go in, and in the storage account itself, there is an option where I can have them fail over to another region as well. And you do that within the storage account. So depending on, again, which one you're working with, then you can definitely pick, there is disaster recovery options. And then the last one in there is your network security and resilience. So the network security, and I mentioned this earlier, that something like application security groups, you can do that in a single subnet. But the other ones too is, if we were to go back to our environment, so let's go back in here, and go up here, you can see that the security in here is, well, what's the biggest thing that you want to implement right here? I'm drawing that like right here, and can you see what that kind of looks like? Doesn't that look like a wall? Maybe not, but anyway, that's what it's supposed to look like. Yeah, we need a firewall, people. Let's put a firewall in there and really secure that. Let's look at it in our subnets, right? There are subnets in here. Well, how about some NSGs? So some network security groups, so that we can manage what ports and IPs are going in between our subnets even, right? Because you set the NSGs, they work at, our subnet level. They can even do it at the IP, but again, what's that? The more you do, if I was to go to every IP and set an NSG, that's going to be more work. So this is why we want to create a subnet and then allocate your security in that subnet. You learn about that when you take our Azure Administrator course and Architect course. They really help you design these reliable environments so that you're not, causing so much work for everybody. Okay. So that in there was talking about the network and resilience. So in that exercise, we talked about an existing architecture. We looked at, they had one web application, one storage account, one database. They had no firewalls. Horrible. It was a horrible environment. No, I'm just kidding. But anyway, so then we went through and we broke it down on a whiteboard, right? We looked at how we can use scale sets. We can use availability sets. We can use replicas on the databases. We can replicate the storage accounts. Hey, let's put in a firewall. Good idea. And then, load balancers. I didn't really get into that, but load balancers will help. Obviously you'll need them if you're going to have multiple VMs. And then the other thing too is looking at, in our subnets, let's attach some network security groups. Let's make sure that we're managing what IPs and ports can come in. Okay. So now let's take a look at the next exercise. All right, so now let's look at exercise 2. Exercise 2 is going to discover and generate WAF recommendations using an APRL script. We're going to learn about what that is in a second. So it's going to assess and remediate an existing application for reliability. So let's start this guy. So in here, we're going to go in, and this is, as you can see, this is an interactive guide. Again, you're going to get access to do this later. In this interactive guide, we're going to go in and we're going to initiate a PowerShell and download the well-architected reliability assessment collector script. We're then going to run that script, review the results, and then download the data analyzer script. And then we're going to run that against an action plan. So let's go through and do this. So we're going to go in and initiate, first of all, the PowerShell and then download the script in here. So I'm going to click on to open PowerShell. In here, we're going to run the command and go to our main CD /. It takes us to our C drive. Click to enter, and we're going to create a directory called WARA. So that's where we're going to store everything. And that creates that directory. We're then going to go in and we're going to go to that directory and we're going to run this command. Right now, this command is going to download the script for us. And I'm going to run that. And then now, once the task is complete, we're going to go in, click continue. And now we're going to run the script itself. So I'll click continue in here. And so here's the command. And you'll see in this command, note the information in here. First of all, you've got to put in your tenant ID, right? So this is going to be a unique ID for your tenant. You also need your subscription ID. And that's going to be a unique ID for your tenant. And the best way to do that is when you go into the Azure portal, you can see that information. And here, let me show you quickly. So now I'm going to open up my portal. And to get that information, I can go into my subscriptions, click on here, click on my subscription name, and then in here, there's my subscription ID. And I can just copy that. Right? And then when we go to the tenant, this is where I'm going to go into Entra. Right? Click on that. And then there's our tenant ID. So the tenant, remember, is associated with, I still like to say this, but it's Entra, which is your Active Directory. Remember, it used to be called Azure Active Directory. So your Azure Active Directory, which is your Entra, also will be where your tenant ID is. And then the subscription is, that billing identification that you'll need. So once you have all that information, you then will run this command, right? And when you run that command, what that does is it's going to run against that tenant and subscription. And what you'll need to do is you'll need to have an account that has access to that script. Normally, this would be a subscription owner. So I'm going to go in and click on that account. And then that shows that it's authenticated, right? So the PowerShell script will need you to authenticate against it. And then I'm going to go back to my PowerShell, and you can see how it's running this PowerShell script. So now it's completed. We're going to go in, and we're going to review the results now. So let's click Continue in here. And in here, this is where it collects all the data, and it puts it into a JSON. Right? JSON's it's kind of one of those. I like to go. It's not the prettiest programming language, and I apologize if I offended you and you're a big JSON developer. But one thing that I love about JSON is that you can really query it. So if you've got great JSON query tools, and this is why it's used quite heavily, especially in the cloud, then you can definitely get into using your JSON query tools. So now it's collected it. Now we're going to download the script, right? So we happen to have a tool to do that. So now I'm going to click on here, enter the command. Here's the command where it's going to grab that script in an AKA file, AKA also known as, those are our web applications. And you're going to run this command, and then it downloads that. So now it puts it into a file explorer in my downloads. We'll click on that, right? And then we're going to run the script. And there's the command. So you can see this is the file that was generated back in here, right? So you generated the file, and then you're going to reference it against this script so that you can view the results. Okay. Click A, so I'm going to accept it all to install all the modules, right? Because it's all working through PowerShell. Okay. Then we're going to go back into File Explorer. And then now you can see there's an Excel doc. Right? Click on that, And that's that. So now what you saw in there is I downloaded this, the WAR script, ran it against my subscription, and then I was able to see the results. Okay? And that was exercise 2. So now let's move on to exercise 3. And exercise 3 is going to review the action plan and prioritize recommendations. So this is going to assess, and again, we're working with remediating, working with this environment. And we're going to look at the action plan and prioritize those recommendations in here. Let's give it a second to catch up. Click continue. So we're going to review that action plan. So that was the one that I just created. And then we're going to filter and prioritize those recommendations. So remember, we went through all of this in the last exercises. We downloaded the script file through PowerShell. We specified our tenant and subscription. We ran it, and now it generated, and then we downloaded another file to generate the Excel doc. Now the Excel doc is there. Now we can actually, let's take a look at this plan itself. So as you can see in here, there is what we call our best practices. So this reminds me, back in my day, we used to call this, oh, wow, it just came out of my head. So I remember back in Windows Server days, you could always run these tools that would generate, these best guidance. And these best guidances, they're really good for, determining, am I meeting the expectations or the best practices that we recommend based on customer feedback. And what it does is it looks at what you currently have in your environment. So right now it's saying use managers for virtual machine disk. Azure is retiring managers. Actually, that wasn't a very good example. Let's do this one. Replicate VMs using Azure Site Recovery. So it's telling you that replicating Azure VMs via site recovery, here, let me show these tools here, every few minutes, ensuring that. And then when I go in and I scroll a little bit more over, you can see in here, not only is it going to make a recommendation of best plan, but it's also going to give you a link where you can actually read more about that. Okay? So as you can see in here, it's very useful. It looks at what you have and then makes those suggestions, right? Gives you an idea of, what you should be doing. You can see, there's a whole bunch in here. So in here, there's 79 recommendations were found. And when you see those 79 recommendations, some of them, you might sit there and go, I don't really need to do that. That's maybe my environment, it doesn't have any external connections. So I don't need to go in and apply, multiple firewalls at every entry and everything like that. Some of these services, you might just disregard, but really look at that, right? Look at, when you disregard a recommendation, what is the implications of disregarding that? And that's what we've been talking about, right? Or we will be talking about later on as well. Or have been, sorry, I apologize. Okay, so now you can also go in and filter, right? So in here, implemented. So once you've done and you've implemented it, then you can go in and make sure you're monitoring this as well. And then from there, you can say, is it implemented? And now I can filter on things that haven't been implemented based on the recommendations that we suggest. The other thing too is I can go in and I can filter on the impact. So again, maybe the low impact ones, you're gonna kind of like, what, I'm gonna not prioritize those ones right now. Right now, I really need to go in and I need to prioritize on the high ones. And this is where you can go in and see that. And then all of our different types of resiliency categories, right? You got your DR, governance, high availability, monitoring. You can see it's all categorized as well. So I can really go in and I can filter on that. And then the impacted resources, right? So what's being impacted? excuse me. So this is where I can go in and I can see what are being impacted based on my filters as well. Now you can sort by only important recommendations, right? And you can see it here. And then from there, I can sort by them. Right? So in the impacted resources, you can see they're highlighted in red in here. And so then you'll know what ones what has been implemented and what hasn't. Let me go through. So there you go. So now we're going to sort it by prioritizing as well. And if there's any out of scope. You've also got resource types, you've got outages, you got retirements. And in here, you also got your pivot tables as well. So giving you, nice charts and everything in here. So you can actually see this in a nice visual, appealing way. So that was exercise 3. So that was taking the WARA script, running, that was an exercise 2. We ran the script and then against our tenant and subscription. We then got a tool to generate an Excel doc because when we ran that script, it built a JSON file. So actually here, let's kind of write this all out here. We'll go to my messy little book here. So we went in, step 1 is we went in and we ran the WARA against our tenant and our subscription. And when we did that, what that did is that generated, right? That generated us a JSON file. Then we downloaded, and both of these we had to download, right? If I can spell download right, goodness sakes. Okay, then we went in and we downloaded the script. So, and that script took that JSON file and it generated in an Excel doc. And that was all in exercise 2. And then with exercise 3, with exercise 3, we went in and we went and reviewed, that Excel doc. And when we reviewed the Excel doc, you could see all the filters that you could use. And my favorite is you got pivot tables, right? That's, going through an Excel doc, especially if you saw all that information, it could be like, whoa, this is overwhelming. And so you got your filters and you got your pivot tables and your charts to really help narrow down to what you're actually looking for or what what you're interested in. All right, so that was exercise 3. So next up is exercise 4. So exercise 4 is going to generate reports from that action plan. So now really getting into really fancy stuff. This is, working with your power, and that's one of the things, like, as we saw in here, it created that Excel doc. Now, if any of you are data analysts, then you know what the potential that you can do with that Excel doc against, the Azure tools and Microsoft tools. So we run the script, right? And we generated that. Oh, wait. There we go. And we run that. And it creates this second file. And this second file is our Word template for that assessment report. So you can see in here, first thing, go in, generates run this PowerShell script that generates the report. Then it goes in, creates that assessment file, and now it creates a Word doc for us. So it creates a PowerPoint as well as a Word doc. And so now when we go in here, you can see we've got 2 new files that we can now work with and get more information out of our environments. So now in here, what we're going to do is we're going to run the command that runs the reports generator. Now, notice in here, it's going to go in. Let me get my Sorry, I'm just trying to click in here. So now in here, you can see there's the PowerShell script, right? And here's the workload name. So whatever your customer information, and then there's the Excel file in here that it's going to run against. Okay. Click on run there. So that generates the Word and PowerShell points, or sorry, Word and PowerPoint reports based on your analyzed data. So we'll click on that, and now we're going to go in and review these reports. So you can see now we've got an assessment report, we've got an executive summary presentation, we've got a mandatory template, right? Those are both our PowerPoints, and then they saw the templates. So to kind of sum this up, is the first two where it generates these templates, right? So it generates these templates against your environment, and then what it does is you run the command again to actually generate the report itself. So now we're opening up this Word doc. So the reports generator automated the process of creating what we call a comprehensive report, right? And I'm just kind of reading what it's saying over here. And this is from the analyzed data and the provided template. So this is where you create the template first, generate the template first, I should say, and then from there you generate that that report. And in here you can see all the information about your environment. Right? This makes life so much easier, doesn't it? I look at these reports and what they, what they're doing. And I remember, I was like, oh man, I wish I had this 20 years ago when I was a server architect and I had to generate these reports manually, right? So this is automating all of this for you, making all this information right at your fingertips so quickly and automatically, so you don't have to go through and drill through your environment. And so as you can see in here, it's going to give you these summaries and tell you what's going well and what's not going well in your environment. And it's all based, as we look over here, you can see in here, you've got, your baseline resilience, your metrics and insights, the health and risk recommendations, the design, platform, and support recommendations, and your next steps, right? So there's so much information, as you can see over here, that you can get, that gets in that report. So now if we look at the executive summary presentation, wow, look at this, right? Unbelievable. So now you're gonna look like, your your leadership's gonna look at you and go, look at what you did. And you're like, oh yeah, it took me days. Don't tell them about the report, just kidding. But yeah, you can see in here all the information you're gonna get. Right? So now you can present this to your stakeholders and say, look, give me some more money, or let me, I need to work on our environment. We need to make it better. Here's where, we need to, make things more reliable and secure and cost optimization. So working with all of those pillars. Okay. So now you'll see some of these slides have a solid red bar, and I'm just kind of reading back what it said there. I go back here, because across the top that needs to be, here. There we go. Some slides have solid red bar across the top that needs to be removed. Each one of these slides needs to be reviewed or customized per the instruction in the red bar. Right? So this is what, as you can see in here, as you go through, you'll see these red bars in your report, and this is where you want to make sure that you're modifying this. And yeah, just like any deck, that you get, you're always going to go through it and make sure that you reviewed everything. And so you can see this chart was created from a pivot table in the action plan. And then you've got your baseline and metrics. And then your health and recommendations, high impact. So you can see it breaks down by high, medium, and low impact. And going through all that. So a lot of information in there. So as you can see with exercise 4, what that did, let's go back to my whiteboard here, is with exercise 4, you went in and you created the templates, right? Because it needs something to use to generate this report. And then from there, you generated the reports based on those templates. And it created you a PowerPoint deck as well as a Word doc. And those are the information, then you can use that information then against, or not against, but with talking to your leadership team. And we'll click continue in here. And so as you can see in here, what we're gonna do is we're gonna create a virtual machine in another zone with the same region. And that's gonna figure IIS. We're gonna create a load balancer, create the virtual machine in a secondary region, create a global load balancer, enable geo-replication for Azure SQL database, and then perform a failover with that SQL database to a secondary, and then set up our storage account to have redundancy. Does this all look familiar? The only thing is that I talked about virtual machine scale set, but think about when I whiteboarded, this is kind of what we're doing in that initial exercise 1. Right, and there's exercise 1. So there's our existing application architecture from exercise 1. And now we're gonna set up this new application architecture. Right? Actually, let's do this. I'm gonna grab my snipping tool, and I'm gonna go in, and I'm gonna grab all that, and let's paste that on my whiteboard so we can reference that later. There we go. So now we've got that reference. So this is, taking exercise 1 and that current environment that they have, and then using all the recommendations based on, exercise 2 and 3 and 4 reports, reading through that, working with your stakeholders, working with everybody that's involved, your security administrators, your network administrators, your Windows, Linux, whatever VMs you're using administrators, your developers, your database administrators, your data administrators, all of that, working with all of them, and in a cohesive environment, and making sure that you're meeting all of the recommendations, or not all, but the majority of the recommendations that are going to meet what you need in your environment. And that what you need in your environment is always, what is your SLA? So what are your service level agreements? And based on that, now you can start building this environment out. Let's go back to our exercise. So now, the first thing we're gonna do is we're gonna create another virtual zone within the same region and configure the IIS application. So this is creating redundancy in that single region. We're gonna click on virtual machines, we're gonna go create that virtual machine, select my resource group, right, which is the WAF reliability. Then in here, I'm gonna go in and I'm gonna put in the virtual machine name, select my zone. So remember with zones, if I really want that redundancy within a region, and this is within a region, then I could put it into a different zone, right? And which I am. So again, let me go back to here. What we're seeing in here is you're actually putting these machines in different zones. Right? So notice in here, zone 1 and zone 2. But this is a single region, right? So you have a single region, and then we're gonna build another, that was a fun little shape it did there for me. Back up there. And then you're gonna build a secondary region, and that secondary region, you're basically, so you'll notice each region, they're basically duplicated, right? So because you're doing a failover, you're duplicating the regions. And that's a key thing to know. So now what we're gonna do is what you're going in is you're duplicating your region. And so that's gonna give you that, failover capability. Let's go back over here. So we're gonna go in and we're gonna scroll here. We're gonna select the image. Right? So in here we're gonna look for a Windows server, and we're gonna use the 2019 server. So when you're creating a secondary machine, one of the things you'll need to make sure is it's the exact same, right? And what I mean by the exact same, besides the username, or not username, password, besides the computer name, is the same image is what I'm trying to get at. And then now we set up our ports, right? So we're going to be using HTTP ports and RDP. RDP is so that we can remote desktop into the machine if we want. This is, again, this is an interactive guide as an example. If I was doing this, I'd be like, if I was teaching like my admin class, I'd be like, do not do an RDP port. Never ever do you do that. But this is an interactive guide. It's just trying to simplify it for you. Because some of you might be sitting there going, what? Why would you use RDP? Why would you use Bastion? Right? I agree. But let's just smile and nod at this interactive guide. And then in here, we're going to click on our disks. I go through, set up our operating system disk, right? And we're going to do that as a standard SSD. And then we're going to configure our networking. And we're going to put it in the front end network. Because remember, we're building another VM for our application. So that's going to go into our front end. And then in our management, we don't need anything in there, monitoring, and then we're going to review and we're going to create that. So this creates that secondary VM in a single region. We're going to go to the resource, and now we're going to connect to it. See, this is what I recommend, is Bastion. Bastion is better because it uses port 443, not 3389. But in this interactive guide, we're going to continue. They're just using 3389. So now we're going to use the open it up and connect to that machine. Right? Log in with our password. So we created that password when we initially created the VM. And here we go. Open up PowerShell. And now we're going to run the PowerShell command. This command, what this one does, as you can see in here, is it's going to run the IIS. Right? This is installing a Windows feature. So if some of you are familiar with Windows servers, running a PowerShell command like this will actually install the IIS role on this server, including the tools. And the management tools are the UI. Now in here, I'm going to run the command and I'm going to remove the default HTML file because I want to put in my own HTML file. And this is the information, then I run that, and then that's going to put in my own HTML file. So it's going to default to the same, essentially what I'm doing is I'm making sure that this machine is a duplicate of the other machine by running these commands. All right. And that goes in, and that finishes running that, and then I can close that machine up. So there we go. So we created our second VM. And when we created that second VM, it got its own public IP. And we're going to copy that public IP. And we're going to make sure that I installed the IIS properly. And I set my default HTML properly. And I did. Well, the interactive guy did. But essentially all what I just did there, now I'm verifying that everything worked. Okay? Now let's close that up, and now we're going to create a load balancer. Now, which load balancer? Does anyone know how many load balancers there are? Oh my goodness, there's so many. All right, let's have fun with this for a second. So when we think about load balancers, there's actually 4 load balancers that are essentially used all the time. We have the ALB, we have the App Gateway, we have the AFD, and we have the TF. And you're like, really? Acronyms, Sarah? Just kidding. So yeah, we got Azure Load Balancer. This is what I like to call a regional load balancer. And this is a layer 4 load balancer. We've got your App Gateway, Application Gateway. I'm just going to leave that short, else I'm going to run out of room here. And that one is also a regional load balancer, but this is a layer 7. So there's a difference between these two, layer 4 and layer 7. And then we've got something called Azure Front Door. Azure Front Door is our global load balancer, and that one is our layer 7. And then Traffic Manager this one is also a global load balancer. And this one is layer 4, but it does have some DNS capabilities. So with these different types of load balancers, you have to think, when you're attaching a load balancer to your virtual machine, you're always going to need a regional. So you need a regional first, and then when you want that redundancy, so go back up to my image here. So the load balancer is, you can see right in here, you've got these two. These two will be your regional. And so that's going to be either ALB or App Gateway. And you're saying, well, when would I use ALB over App Gateway? Well, that depends, right? In my example, I would just use Azure Load Balancer. I don't need a layer 7 load balancer because I've only got a single web page. So Azure Load Balancer would be very fast for me instead of the App Gateway. The App Gateway is great for more complex type of web applications, but it's a bit slower. Not much, but definitely I want the speed. And then you've got your global load balancer, and you've got Azure Front Door, or you can have Traffic Manager. In this example, I would use Traffic Manager. Right? Traffic Manager, because that's going to give me, Traffic Manager has what we call routing methods, and the one that's going to give me that I would use priority. Because what we're concerned with is failover, right? So that's all what we're concerned of is failover. So the Traffic Manager priority is going to give me that. So this will be my priority region, my primary region, and then my secondary. And that allows me to failover. So let's look at in here, and you can see, right, when I click on create, actually let me go back here once. See, there's the 4. Right? I didn't talk about content delivery networks. Content deliveries are caching, right? And that's all part of the front door. But there's the 4. And as you can see, yeah, they're quickly picking that Azure load balancer. And so what I'm going to do in here, I'm just going to click on this quickly, is that's going to go in and create that load balancer. And I need the load balancer to be connected to my front end. And my front end is going to be my IP address of my web app server, right? And I'm going to save that. Oh, sorry, the front end. I said that wrong. Let me go back there. Here, I explained that wrong. So what we want to do is we want to go in, and when you create the front end IP, the front end IP is the IP address that users are going to connect to. And then from there, that's going to connect into saying a name, setting up the IP address. So you need to make sure you've created a public IP before you create the load balancer. They kind of skip that step in this interactive guide, but you'll need a public IP already created first. And then, now it connects to my backend pools. And the backend pools are gonna be my virtual machines. Right? So I click on add here, and there's the 2 VMs, and I click on those. So my recommendation, and I don't believe they talk about this in this guide, is once you create this back end, then I would recommend removing the public IPs off of those machines. Right? You don't want them on there anymore, because they don't need them. You're connecting through with a load balancer. Now I set up my rules, right? So what is the rule for that? It's where you're going to use HTTP. There's my front end IP, and there's my back end pool. So this is the rule that connects everything together. And I can set the port and then the back end port. Again, you know, security-wise, I would use 443, but this is just for this interactive guide. There we go. So now that load balancer is set, I can then go in, it runs a final validation to make sure everything's good, and then I go ahead and create that. Now I can go to the resource, and I can see everything's created fine. Okay, so let's move on to task 3, and this is going to create now the secondary virtual machine. right, in a secondary region. So now this is essentially what we've built, right? We've gone in and we built this environment right here. I'll probably start breaking some of this out. So in here you can see this is what we've already built now. So we've got the 2 web applications and we've got our load balancer. And we've got the public IP, right? So that's all been configured. So now we're moving on to the secondary region. And in here, same thing, we're gonna log in and we're gonna do this one through our PowerShell. So logging into our tenant, entering our password, right? So that goes in. And then now we're gonna put in a subscription. Sorry, yeah. So we're gonna put in our subscription and then go in and enter all this. So the 2 virtual machines reside in separate zones within the Central U.S. region. So now we're going to create a new resource group in the Southeast Asia region for a 3rd virtual machine, as you can see in here. Then we're going to run the command, and that created the group. So it created our resource group. So now here is where we're going to go in and run the command. And this command, what this does is this is a new Asia resource group deployment. And so with the AZ resource group deployment, what that does is it allows us to deploy something against a resource group name. And then there's the PowerShell template that we're going to be using, right? And so we're going to go through and run that. And that's going to create our virtual machines. So now here, if I click on virtual machines, you can see the new virtual machines. So the the second VM that we created, we did that through the portal and you saw that. And then these 2 VMs that we created, we just did that through a PowerShell. So see the difference of speed? You know, I am such a big advocate for, PowerShell and templates and automation. So you saw, how easier that was, or faster, I should say, that was with creating these 2 VMs. I created 2 VMs, and half the time I created a single one in the portal. So now let's move on and create a global load balancer. Now in my example that I was showing you on the whiteboard, or not example, when I was talking about the 4 load balancers, so remember when I was talking in here about, you've got your 2 regionals and your globals? One of the things that I should have mentioned, and I apologize that I didn't, is that this one can also be global as well. And one of the things for the Azure load balancer is that because this is a simple web application, you're going to be able to use this Azure load balancer both for global and regional. And it does support the both. And like I said, for the web application, it's just a single web page, you can get away with this. Now, if you're having, let's say this web application was an e-commerce site, or let's say, you had multiple web domains. So let's say you had fabricam.com and contoso.com on these web application servers. The chances are you're going to be looking more at these global load balancers, right? The Azure Front Door and Traffic Manager. But because it's very simplified, this application, then I can go in and I can create the Azure Load Balancer, right? And that Azure Load Balancer in here, I can go in and you can see down in here, it's going to give me the ability to create a global. And then set my IP. So go through all of it. So you did this before, or I showed you this before. Same thing. You got to do it again in the secondary region. Setting your back-end pools for those this is for the southeast region. Right, so you just essentially duplicated everything. Okay. Clicking through this quickly, but just so you can get the idea. Adding your rules, your front-end IP, and then your back-end. And then set your port and save that. And then review and create. And so that's going to go in and create your global load balancer. And you can see that. So next up is task 5, and that's going to set up the geo-replication for your SQL database. So in here, click on the SQL database. So now you'll see that under the data management, this is where I can create replicas. And we talked about this in exercise 1 when, I said, one of the things that you probably would want to do for redundancy is going in and also creating replicas. So in here, this is the steps that you would utilize or do to create replicas on your SQL database. Now, I know I'm going through this quickly, but you'll be able to see this and do this yourself in this interactive guide as well. Right? So creating that geo replica. And again, the geo is going to give you that ability to have it in a different region. Right? So you can see now it's in East US, but the original one was in Central US, and then that deploys that. Now we can go to the resource, and I can see that newly created geo replication, the secondary. Now I'm going to try a failover to make sure it works. So looking at my replicas, you can see the two. There's Central US, that was the original one, and then my failover one, which is our East US. Click on here, and I'm going to do a forced failover. Click on yes, and then I'm going to make sure that it works. And then I refresh,